So let's start with fundamental of Spring framework. So the thing is that whenever we talk about the Java application development, it requires a lot of code actually. So we need to remove that boilerplate code actually. So we don't want to write so many code. Let's take example of creating Java connection and writing and saving data into the table. If you want to write that particular code, then you need to write unnecessary code, registering, loading class driver, registering to the driver manager services, and then getting the object of connection, and then you have to write the queries. Okay, so many lengthy code you have to write. So but in the spring, in the case of spring, just you need to write save. So in the business logic, what we want to save some object here. That's it. So it removes boilerplate code which is not required for business purpose. Okay, so that's why industry adopting this Spring framework, and it is very powerful framework for Java development. Any other features of Spring? It makes a developer life very easy because just you need to create application ready to you can I can say in other word, it provides ready to work project for you. You need not to worry about dependencies and all. So the major part of it is dependency injection. We will talk about later in dependency injection. Dependency is nothing but whenever one class requires some other class. Okay. So in that case, the first class is dependent on second class. So the second class object is required to be injected in the A class. Okay, simple. Let's say we have class A, and in class A we have object of B. So the B is the dependency for this particular class. So these dependencies can be injected through one way to we can create by using new object, and we can inject that dependency. But another way is to some other, it means framework has to provide the flexibility, and it will create separate object and it will automatically inject to our class or our object. So this is called dependency injection. Okay, let me create a simple example that okay, let me create one simple class how Spring works actually. So I will create one hello world example for Spring application. Okay, so how we can create a simple, let me create one hello service. Okay, in this hello service we don't have anything. Let me create just a single method. Okay, so let me create one method say hello, which is returning some message, or we can say hello service. This is our hello world application in Spring. Okay, I've just created one Spring service. Okay, inside this Spring folder, and now I want to configure. So I have one more thing, app config. Okay, so here we have one annotation that is configuration, and inside the configuration we can declare any number of beans. So that hello service I want to be injected as a bean inside the IOC container. Okay, let me discuss about more. Dependency injection can be achieved through IOC. IOC means inversion of control. Inversion of control means instead of we are creating object using new keyword, some other or external component has to provide the or has to inject the properties or field, or we can say dependency inside the class. So we need not to create object using new keyword. Container will take care of it. So we have IOC container in Spring Framework. So container manages its life cycle. Okay, it is responsible for creating the bean and destroying the bean. Bean are created inside this IOC container, and whenever it is required inside the class, automatically got injected. Okay, so dependency injection is nothing but design pattern. Okay, we can say it is a design pattern. Okay, and IOC is principle. So inversion of control is a principle which is nothing but inversion of control. It means that a container will provide dependency for your object. Okay, so dependency injection worked on which principle? Inversion of control. Of control is nothing but a principle. Okay, now later we will discuss types of dependency injection. We can have setter injection, constructor injection, and field injection. Three type of dependency injection we do. See, loosely coupling. If you want to change the implementation also, you can also change the implementation as well. Without, so it provides our code very maintainable. Loosely couple, loosely coupling means we can change easily. That is correct. And tightly coupling means if we are changing, something might uh, break. Okay. So in that case, it is better. It provides better maintainable code. Okay, easy to test, and it provides flexibility to upgrade our code as well. Okay, that's why loose coupling is required. Here I have just created one hello service which has only single method which is returning. So I want this class object should be injected into a IOC container. Okay, so how can inject that this class object? by by defining it as bean here, bean annotation. The return type should be the hello service. Okay, and here I want to return instance of this particular class. Return new hello service. So I have injected this hello service object into our IOC container. Okay, now let's test this application. Let me create one test class here. I will write one main method here. This is the hello world example. I have just injected one bean inside our configuration class. Okay, and this class and now I want to get the object from our container. Okay, actually what we did, instead of creating object somewhere else, we have uh, created it as a bean, and we will access from other part of the application. So I just wanted to access this hello service object from this main method. Okay, that's why I've created this test class, and now I want to access this container. So we have application context. Okay, in application context we can bean by name. So we have one class here, new annotation config application context. So here we need to provide the configuration file name. So what is the configuration file? We have this app config. So let me provide this app config dot class. Now just we have created instance of this particular application context, and inside the application context it is nothing but the container. Okay, so what we have discussed so far, uh, we have added our object into IOC container. Okay, and now I want to access this IOC this particular object from IOC container. So it has some method like get bean. Okay, whatever the bean you have declared inside as a bean at the red bean, you can access from there. So what is the type of this particular bean? Hello service. Okay, so we have context dot get bean method. Okay, and here we have to provide the type of object, which type of object we do want. So we want hello service dot class object. So it will create, instead of we are creating object using new keyword, we are getting the readily available object from the context. So this object is already available. Whenever you load the class, it will create bean, and it uh, the bean is ready to access. It means that we are not creating object on demand as well. So initially we are creating object. That is one more advantage of that. That too, we are not creating multiple instances of it. Just we are creating single object of it throughout the application. So by this we can save memory as well. Okay, so by default you are creating object as a bean. By default it is the scope of this bean is singleton. It means that one for one container, uh, for it is one per container, we can say. So now we have hello service. Okay, because we are getting bean of this type. Now let me call the method inside this hello service. So just call that method hello service dot hello service. This is the object and this is the method. Okay, it will print hello world in case of there is no error. Okay, let me save it and run this particular application. Test. Just we are returning and we are not storing. So let me store this object. But just info we are getting. That's it. So whatever the result we are getting, just let me print as it is. Okay, hello world. Now got it. So whatever the object we have created inside the container, we can access by annotation config application context. This is nothing but we are accessing the container by using this, and we are passing our configuration, whatever the configuration we have done. So there are two types of configuration. One is annotation based configuration, other one the old type is XML based. So nowadays we are using only annotation based configuration. We are not using XML based configuration. So I will show you how we can also access the XML based, but for time being this is how we are declaring our bean inside the configuration class. This is called as our configuration class where we are declaring our beans. So it will get injected to, I mean, the container execute this file and it will create object of this particular bean, and it manages its life cycle inside the container. So this is the hello world example of Spring fundamental, we can say. How we can create a bean, how we can access the bean. That's it. Okay. Now second topic we will cover dependency injection. How we can inject dependency in one class. Okay. IOC, inversion of control, IOC container. If you are declaring a bean, that you need to declare inside the config file. Okay. As a bean, if you want, then you need to declare here. But by default, these are if you are not declaring any scope, this is singleton only. This hello service is singleton. Okay, now we will create one more. Okay, let me create one more package for dependency injection. Okay, so inside this dependency injection, I will create the same class hello service. But here, one change I will do, I will create one dependent object here. Na? Let me create this hello service. The methods should be same also. Okay, say hello. But instead of returning this object, I will create one dependent object here. That should be private string, and I want to return this message from here. So in this particular class hello service, we are not just returning the hello world. Instead of that, we are returning the message which is dependency to this particular class. We have declared this message object here inside this hello service. So this is the dependency, and this dependency to be injected inside the hello service. We have one dependency, that is message. Okay, and this dependency we want to inject. So similarly, we have to create one more class app config. Okay, here similarly we will create @ configuration. Okay, and we can create bean hello service, and this bean will return hello service object. Okay, and one more bean I want to declare for the message also, at the rate bean public that should be string type because I want to inject this bean here. Okay, this is the dependency, and I want to create object of this also inside the container. Okay, and from here I want to return dependency injection. Okay, so I've created two beans here, and this particular bean is dependency for this, but even though there is a dependency, but I am able to create both bean inside the configuration class, and now I want to inject this. Okay, to inject the dependency here we have to use one annotation, that is auto add. It will automatically auto add that this particular object hello world using di here if we are using at the rate auto add. Let me try without auto add first. Okay, let me create one test class here. Okay, and main method application context is equal to new annotation config application context. Okay, here we have to provide the app config dot class. Okay, now we need to get the bean which is service hello service. Okay, so here we are able to access this particular object, but this object has some dependency. Okay, so whenever we say hello, let me write inside this system.out.println. Okay, hello service dot say hello. Okay, so let me run this. At this particular point of time, as we are not injecting any dependency here. Okay, so what happens, it should return null value. Let me run. Okay, because the dependency is not yet injected. Now let me auto add it. Okay, just we have auto added, and now let's see the difference. This is some type of loose coupling, we can say. Instead of we are creating object, container or external force is providing the object of our required bean. This is called inversion of control, and control is the principle, and dependency injection is the design pattern. So this is the basic example of dependency injection. Flow of code once again. Yeah. The flow starts from here. Okay. What we are doing, we are loading the here we are creating container or loading container. Okay. So whenever container starts, it will check the app config file. Inside the app config file, we have two beans here. Beans are nothing but Java object. Bean is nothing but Java object. In Hibernate, we call it as Pozo, plain old Java object, or beans are nothing but objects only, Java object we can say. Okay. So we are creating object using this container. So container is responsible to create instance of each these class which is declared here. Okay, so basically container creates object using type. So one object of type I earlier told you in whenever we have discussed the inheritance. So I told you in Java everything is type. Okay, and class is nothing but user defined data type. So here just we have created object inside the container. Container you can consider as a box kind of thing. We have created two object inside that box, and just we are fetching those object using get bean method. So I just wanted to access this hello service. Okay, so I am able to access, and if I want to access the message as well, so just I need to write s out text dot get string dot class. So in that case, okay. So here we got this string class object as well. So whatever the type of object you have created, just you have to you call by dot class. Okay. So by this we are able to access the bean. So we are at the time of creating the container, or whenever containers loads into the memory, it will seek for the objects which are available inside the app config file, and it will instantiate those object, and once instantiated we can access from the context by using application context class. See, but what is the default value this message then? Okay, so if you are not auto wiring, it means that the default value of object is always null, so it will return null only. This is called field injection. Okay, we are injecting using field is dependency injection. Okay, so we have created simple config example, I mean hello world example. Okay, let's discuss scope of beans. Okay, so let me create one more package scope. Okay, let me close all these things. Okay, so now let me create one class here which is singleton bean we can say. Okay, let's discuss first scope of bean are means what would be the scope of a bean, where we can access what would be the scope of that particular bean. Okay, so we can achieve scope by using @scope annotation. So everything is available using annotation. Earlier we used to have scope attribute inside the XML configuration. Nowadays we are using @scope So here we can define the scope of bean. The default scope is singleton. It means throughout the container we have only single instance. I mean single object of it. In one container we can have only single object. That's it. And in prototype as many instance. Whenever you are accessing, it will create new instance. Okay. Whenever it is required to create different object, then you should use prototype. And whenever it is required to be a single object, then you can use singleton. But singleton is a default. You need not to declare. Then we have request, session, global session, and application. So request is nothing but one per HTTP request. Requesting, whenever you are doing a request using HTTP protocol, okay. So it will, it will create one instance for one request. Okay. For each request, it will create one instance of it. And for session, one per session. Whenever you logged in and you created session, then it is one per HTTP session. Between login and logout, it should be same. Okay. And global session is it is applicable in portlet web application. It is not useful. And application, I guess, it is used in WebSocket. Okay, so these are the scope of our bean. We can declare using @scope. So here I'm not doing anything, just I'm creating. Uh, just let me create one constructor of. We have public. I'm just creating default constructor. Okay, and just let me write one statement so demonstrate the singleton behavior. That's it. Okay, that's it. I have just created one singleton class. Okay, and I have added one constructor here. That's it. So the property of constructor is whenever you create new instance, it will execute it at once. You know what is the property of constructor? It will execute it once whenever you are creating instance of a class automatically. You need not to explicitly called it. Okay, explicit call is not required for singleton. For constructor. So whenever we are creating object of it, it will execute automatically once. So that's why we have created single class here, and we have. So to demonstrate, we are not creating multiple instances of it. Okay. Now let me create one config class. App config. This is our configuration class, and let me declare this bean. Okay, and here we have public my singleton bean return my singleton bean new. Okay, just I have declared one bean here. Okay, and we have written and nothing here, except this constructor. And now let's test this. Create this bean as singleton, scope as singleton, even though the behavior is default, but let me create singleton. Okay, so we have created this singleton bean here. So now I want to demonstrate how we can check whether the object is same or not. So let me create one main class here, and same code we have to write application context. Okay, and here we have this context here, and let me create new annotation config. Let me access that class cat bean. My singleton bean dot class. This is my bean one. Okay, and similarly I will. Okay, let me create one more bean. So we have two beans. Okay, and let me print the result of it. Bean 1 is equal to 2. Okay, and now run this. It should return true. Okay, singleton singleton bean instance created. Okay, okay, bean 1 is equal to bean 2, sorry. In that case also we are getting the same result. Bean 1 is equal to. Okay, let me do one change here. Instead of singleton it should be prototype. Okay, so if you see here, the single instance bean instance singleton bean instance created printed two times. It means that the object created two times whenever you are accessing, first time and second time, and both objects are different. Okay, so in the case of prototype, every time whenever you want to access, it will create new instance of it. Okay, in the case of singleton, it will create only single instance of it. Okay, so these are the scopes, and HTTP and request session we cannot implement here. Now let me show you the same thing using XML configuration as well. So in the legacy application, how we are accessing these objects. Spring XML. Okay, so the same thing we can achieve through XML configuration. So for XML configuration, we can create XML file here, Spring Bean configuration file. Okay, here. So inside this application config XML, we can declare any number of beans here. Okay, so let me create one class here. Let's say person or student. Person can have two inputs, maybe private string name, private int age. Let me create one constructor here. So here we can declare bean here. And here we can provide the class name. So we have Spring XML dot person, and here we can define the init method or scope. Okay, whatever you want. Okay, let me create constructor args. What is the first constructor argument? That is name. So let me provide Aman, and one more constructor argument is required, that is int. Let's say 22. Okay, so I have created bean using this XML configuration. Inside the resources folder you can create bean like this. Okay, now let me create one test class here. Okay, so here we have to use this XML configuration. So we have to get the application context object, and here instead of that annotation, now we have to use XML. So we have class path XML application context. Okay, class path XML application context, and now inside this we have to provide the file name application config. Okay, so now we have to provide this application file name refactor. Okay, and here one more thing we have to provide, which is id. Here id is something like that, whichever object name we can say. So by this id we can access that bean here. And here we have to get the person object. Okay, now we need to typecast it. So the same thing we can achieve through XML configuration as well. One more thing, let me create here toString method so that we can print our object. Source generate toString method. What the s out person. Okay, let's test this whether the XML configuration is working as expected or not. Okay, so if you see Aman, whatever the value we have provided inside the XML configuration file, we are able to access this. So earlier what we would do, we used to have this XML configuration. Annotations nowadays came into the picture. Otherwise, we would have this XML configuration only. Nowadays, we are adopting more annotation based configuration. Okay, why? Because XML is extensible markup language, which is some other language, and Java supports annotation based, that is Java related language only. I mean, Spring supports Java, promoted Java related language only. Okay, so this is how we can access these beans from XML configuration as well. Okay, now next topic. So let me create lifecycle. So now we need to understand the life cycle of our bean. We can write multiple beans inside this beans. Actually, beans is a collection of bean, na? So you can create any number of beans here. It is similar to at the rate config only, na? At the rate configuration only, because there we are declaring as a Java object. Now here we are declaring into the form of XML. So XML has whenever we start some tag, it has to close. It will have to close. Okay. So life cycle of a bean. Can anyone explain what do you mean by life cycle? In it and at the end, destroy. Okay. So here between these things we can perform some operation. So the similarly the life cycle of bean is similar. We have init methods, okay, and we have destroy method. So init method, after initializing a bean, it will get executed. Okay. So when bean is being created, I mean it will be initialized. Okay. It it means that after uh, property set or something like that, it will be created whenever the init method is called. And destroy, before we are destroying, the destroy method will be executed. In between, we can have some operation also. So the similar life cycle we have in the um, bean life cycle as well. Let me create my bean. Okay, and one constructor here so that we can say the object is being created. Bean is being instantiated. Okay, and I want to, so we can achieve this init by using one annotation post construct, and we can achieve this destroy using pre-destroyed. So let me write here itself public void init. So after instance created, bean is being initialized post construct. Okay, here as out bean is initialized. Okay, and public void destroy pre-destroy bean is being destroyed. Okay, now let me write one more method, do something. Here in between we can do something. Okay, okay, let me test this bean. So these are the predefined annotations which we can use to initialize and destroy our object. If you want to write some code which is required for initialization, then you can write that code inside this block. And if you want to write some cleanup operation before the bean is being destroyed, you can write that code is in this particular block. Okay, so let me create one config class here. This should be our configuration, and here okay, that's it. Now we have to test this. Okay, application context, application context should be context. Okay, and new annotation uh, config application context, and here we have app config dot class, and now we have to get the mybean object. Mybean is equal to application context dot get. Now we can call this method bean dot do something. That's it. Do something is not public, not saved na. ठीक है. Now it is being resolved. Let me run this. Okay, bean is being instantiated, and instantiated means constructor is, we are calling the constructor. Okay, then init method is called, bean is being initialized, then we are doing something, but we are not able to see this message bean is being destroyed. Okay, so to destroy this we have to close this context. Okay, so to close this we have to do directly, we cannot call close method is not available for this. We need to typecast it into annotation config application context. Okay, now it is converted into application context. Now we can call the close. Okay, so let me run this once again. Okay, so bean is being instantiated, bean is being initialized, do something, and bean is being destroyed. So these are the life cycle method which we can achieve through at the pre post construct and pre-destroyed. Same thing we can achieve through annotations as interfaces as well. Two interfaces we do have: initializable bean, initializable. Let me check. Okay, initializable and destroy, disposable. Okay, we can achieve same thing using by implementing two interfaces as well. If you want to write initializable bean, okay, then you need to implement one method. Okay, this should be initializable method, not initializable. Initializable bean should be there. Initialize, initializing bean, initializing bean. Okay, so same thing we can achieve through this by implementing this. Then we have to implement this after property set method. Okay, and disposable bean. So if you want to implement this, then you have to provide body for all the methods which are available in this particular interface. Okay, if you see, it has only one method which throws some exception. So I have implemented this destroy method here which throws some exception. So the same code which we are writing inside this our p destroy method, just we have, so we can achieve same functionality using interfaces as well. Okay, okay, there is no difference between the functionality because it is doing the same thing. You can achieve through annotation as well as implementing the interfaces as well, initializing bean and disposable bean. Okay,